Hello class, I am sorry to be gone today. My daughter got sick this morning, so unfortunately I have to stay home with her. So what we're going to do today is the 3-6 notes. Remember, this is not going to be on your quiz tomorrow. Quiz tomorrow is on 3-1 to 3-2 and it's non-calculator. This stuff, we'll go through it again, but watch the video, pause it as you need. We'll get started here. So we've got the division algorithm for polynomials. So we're continuing our discussion of polynomials, but we're going to be doing some new things with them. So one of the things that we're going to talk about is division of polynomials. So if you have something like f of x divided by g of x, right, you're dividing these two polynomials, you're going to end up with q of x, so whatever the quotient happens to be, plus a lot of times there's a remainder. So the remainder all over the denominator. It's like when you divide two numbers and they don't divide nicely. You have the number plus the remainder over the number you're dividing by. Other way of writing this is if you imagine this and you were to multiply this whole thing by g of x, what would happen is you would end up with f of x equals q of x times g of x plus r of x. So there's two different ways to think about it. What we're going to be talking about is the remainder theorem, because oftentimes when you divide two polynomials there will be a remainder. All right, so the remainder theorem says that f is a polynomial function if f of x divided by x minus c and the remainder is f of c. And the remainder is f of c. And I'll explain what all this means with examples in case you're going, what? The factor theorem. All right, the factor theorem says that x minus c is a factor if f of c is equal to 0. All right. So here's what happens. All right, we're going to do some examples and I'll explain all this stuff. So example 1. Let's say you've got f of x equals 2x cubed minus x squared plus 2x minus 3. The first question is going to be, is x minus 1 a factor? All right. And if it's in factored form, then you could tell. Obviously it's not. So what you do is we use the factor theorem. If it's x minus c as a factor, then f of c will be 0. So, set that equal to 0, you get 1. So what we're going to do is we're going to plug in 1. If you get 0, then you know it's a factor. That's essentially what it means. So if you do 2 times 1 cubed minus 1 squared plus 2 times 1 and you subtract 3, if you simplify all that, you will get 0. Since it equals 0 by the factor theorem, that means that yes, it is a factor. All right. Same idea for part B. Is x plus 2 a factor? All right, so what you'll do is you set that equal to 0, you get negative 2. So you'll do f of negative 2 and see if that equals 0. All right, so you're going to plug that all in. All right, so minus negative 2 squared plus 2 times negative 2 minus 3. If you plug all of that in, you're going to get negative 27. Obviously, negative 27 does not equal 0, so it's not going to be a factor. That's how you can tell if it would be a factor or not. All right, and what we're going to do is we're going to use these to help us factor really large polynomials. All right. Another thing we're going to use with factoring large polynomials is something called synthetic division. I believe you learned that last year. So use synthetic division to depress the polynomial. Depress means to kind of like break it down. Depress the polynomial. So what we have, we're going to depress the polynomial f of x from number 1. Okay, so from number 1, our polynomial was f of x equals 2x cubed minus x squared plus 2x minus 3. Now when we did 1a, we knew that 1 was a factor. So what we're going to do is use that factor 1 to do synthetic division. The reason why we do that is because we know that it's going to go in nicely. It's a factor. So what you'll do is you take the coefficients. You have to make sure that everything is represented. So like if this was missing, like let's say that x wasn't there, you'd have to put a 0 in place of the x. You have to make sure if it starts with x cubed, you have a number for x squared, a number for x, and a number for just a number without the x. So make sure every single spot is represented. We've got a 2 as the coefficient, we've got a -1, we've got a 2, and then we've got a -3. So you're going to write down just the coefficients. All right, and then what's going to happen is you always bring down the first number, 2, and then you're going to multiply 2 times this number 1. 1 times 2 is 2. That number is going to go here. Then you're going to add these two numbers together. 2 plus -1, you're going to get 1. Then you multiply. 1 times 1, you get 1. Then you add. 2 plus 1, you get 3. Then you multiply. 3 times 1, you get 3. Then you add. You get 0. You should get 0 because that is your remainder. This will be your constant. This will be your x of the first, and this will be your x of the second. So the way that this is going to depress is we know that 1 is a factor, so we know it's x minus 1. And then we write this whole thing. 2x squared plus 1x, or just x, plus 3. All right, and that's going to be our polynomial depressed a little bit. We kind of broke it down and factored it slightly. Okay, so that's that one. Example 3, given 2 of the zeros are 1/2 and -1/2. Depress the polynomial. Depress the polynomial, I'm just going to put poly, using synthetic division. All right, so using synthetic division. And here's the polynomial. F of x is equal to 4x to the 4th plus 15x squared minus 4. All right, so if we can do 1/2 or -1/2 first, it doesn't matter. This one, we start with 4x to the 4th. There is no x cubed, so make sure you put a 0. There's a 15x squared. There is no x to the first, so make sure you put 0. And then the constant is -4. From there, we're going to start our synthetic division. We should get remainders of 0. Bring down the first term always. Multiply. 1/2 times 4 is 2. Add. You get 2. Half of 2 is 1. Add. You get 16. Half of 16 is 8. Add. You get 8. Half of 8, you get 4. And yes, we do get a remainder of 0. Then we're going to do it again, all right, with the other factor, -1/2. Again, you bring down the first term, 4. -1/2 of 4 is -2. Add, you get 0. Multiply, you get 0. Add, you get 16. Multiply, you get -8. Add, you get 0. All right. So this is our remainder, this is our constant, this is our x, and this is our x squared. All right, so what happens is we have 1/2 as a factor, so x minus 1/2. We have -1/2, so x plus 1/2. And then we have this thing. We have 4x squared. The 0x you don't really need to put, plus 16. That's going to be our polynomial. So we're using synthetic division to kind of help us factor stuff. All right, so that's kind of how that works. Okay. Let's see. So then we've got something called the rational zero theorem. All right, the rational zero theorem. These notes, of course, are long. On the day I'm gone. All right, rational zero theorem. Let's say that P is a constant, right? And Q is the lead coefficient. I'm going to abbreviate lead coefficient. The possible rational zeros, all right, is going to be the factors of P, so everything that goes into P, divided by the factors of Q. And I'll explain that with some examples. Okay, so let me do example 4. Example 4, you have f of x is equal to 2x cubed plus 11x squared minus 7x minus 6. We're going to list the possible rational zeros. All right, and I'll explain. We're going to use this rational zero theorem to aid us in that. So P is the constant. The constant's -6. All right, so the numbers that go into 6 are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Q is the lead coefficient, in this case 2. All right, so all the factors of 2 are plus or minus 1 and plus or minus 2. So all the possible zeros are going to be the factors of P all over the factors of Q. So you've got like plus or minus 1 over 1, or just 1, plus or minus 2 over 1, plus or minus 3 over 1, plus or minus 6 over 1, all right, and then plus or minus 1/2, 1 over 2. 2 over 2 we already have, plus or minus 3 over 2, and then plus or minus 6 over 2, which is 3. So we already have that. You don't have to list it twice. All right, and I think that's everything. Yeah, so those are all of our possible factors. And so from there, what you're going to do is, let's go to example 5. We'll do more with this. We're going to use a calculator to find one real zero. All right, because trying to figure out which one is an actual zero from that long list is kind of tedious. So we're going to find one real zero on our calculator from example 4, and then we're going to depress it by hand. Okay, so I'm going to skip the calculator part, but you can use your calculator to graph it, and you can see, let me write the function again. You got f of x equals 2x cubed plus 11x squared minus 7x minus 6. You can graph it on your calculator and see where it crosses the x-axis. The one place where it's going to cross is at x equals -6. All right, that's like a nice place where it crosses. So that's the one we're going to use. So again, you'd use your calculator to do that. So we've got -6. We're going to list all the coefficients, make sure every x is represented. So we got 2x cubed, 11x squared, -7x, and then -6. You always bring down the first term, multiply, you get -12, add, you get -1, multiply, you get 6, add, you get -1, multiply, you get 6, and you should get 0 because we found that one on our calculator. This is your remainder, this is your constant, this is your x, and this is your x squared. So since -6 is a factor, it'll be x plus 6, and then this will be 2x squared minus x minus 1. Now with this one, we're not going to stop here because this does factor further. All right, so you're going to have to remember some of your factoring skills from last year. This will factor. All right, it's going to end up being 2x plus 1 times x minus 1. All right, and you've got x plus 6 here. All right, so it kind of helps you to break it down and then allow you to factor by hand from there. Okay. Okay. I think we've got the main idea here. Let's see, I got 2 minutes. I'm limited to a time of 15 minutes when I do this. Let's do this. Example 6, we'll do part of it right now. F of x equals 2x cubed plus 3x squared minus 10x minus 3. All right. What we're going to do is, let's say that we're given -3 is a 0. We're going to find the rest algebraically. Find the rest algebraically. So what's going to happen is you do -3. You're going to have 2, 3, -10, and -3. Bring down the first term, multiply, add, -3, multiply, you get 9, add, you get -1, multiply, you get 3, add, you get 0. So this is your remainder, this is your constant, this is your x, this is your x squared. From there, you've got x plus 3, and then you've got 2x squared minus 3x minus 1. All right, now for this one, we're going to find the other zeros. So we actually have to find the other ones. This thing doesn't factor. So what you would have to do is the quadratic formula. Do the quadratic formula to find the other zeros. All right. We know that the one factor or the one answer is -3. This guy, you're going to have to do the quadratic formula. So you would do the opposite of b plus or minus, your b squared, 9 minus 4 times 2 times -1 all over 4. You'd have to simplify that I'm going to run out of time. So I'll finish this tomorrow, but I think you get the main idea. Good luck.